So we're going to continue with more properties of vectors. Specifically, we're talking about them being parallel or perpendicular to each other. So first of all, if we have two non-zero vectors and they're parallel, if and only if one is a scalar multiple of the other. So you'll notice that the direction will be the same. It could be a negative direction though, but the angle is the same, and we'll talk a little bit more about angles later on. So if we have a vector A, then B is some scalar multiple of that. So for the first question, we're going to use that information that if they are parallel to each other, that there is some scalar multiple between A and B. So I'm just going to look at my x component, and I have 2, and I'm going to say that that's equal to k times s. So x and x. And then I'm going to set up my y component, -1 is equal to k2, and then r is equal to k -3. So I'm going to start with this middle equation because I can actually find a value for k. And if they're parallel to each other, then that k value has to be consistent with the other two equations. So 2 is equal to -1/2 s. So s is equal to -4. And for the third one, I have r is equal to -1/2 times -3, which is +3/2. So scalar multiplication is used with this concept of two vectors being parallel or finding the unit vector. But what if we actually want to multiply two vectors together? That's when we do something called the dot product. So if we read through this definition, the scalar product of two vectors which results in a scalar answer is read v dot w. The vector product of two vectors which results in a vector answer is called the cross product. We're going to specifically look at the scalar product first. So to find a scalar product where we're using the dot product of v and w, this is the formula. You take the x component of the first vector, you multiply it by the x component of the second vector. Then you add it to the y component times the y component. You add it to the z component times the z component. So you would end up with just one scalar answer. One scalar answer. Now we're also going to use the dot product to find the angle between two vectors. So it says here, consider the vector, and that has a label v1, v2, v3, and then another vector w. And basically, if they start from the same point and we're trying to find the angle between them, we can say that we're actually it has a length of w minus v, and that's because we can look at it like if we change the direction of v, so it's really going this way, so that would be -v plus w, and there's our resultant vector in between. So to find that, we take the dot product of the two vectors over the magnitude of each vector individually, and then take the cosine of it. These are some written properties. Notice that if we use the dot product of v and w, it's the same as w dot v. If we are taking the dot product of one vector twice, it's as if we're just squaring it. And here you can see that we can actually distribute, and we can also take the dot product of a resultant of an addition vector and another one. So again, distributing v dot w, v dot y, w dot x, and w dot y. So let's actually put some of this stuff into practice now. So I want to find the dot product of PQ. So P dot Q. So I take P vector and Q, and remember the formula. I'm going to multiply the first two together. I'm going to add it to the multiplication of the second two, the Y components, and then I'll add it to the Z component. -1 times 2. So we get -2 plus 0 minus 2, which is -4. Now we're going to use that to find the angle between the two. So cosine theta of P dot Q over the magnitude of P and the magnitude of Q. So we already found P dot Q, that's -4. Then if I'm going to find the magnitude of P, that's the square root of 2 squared plus 3 squared plus -1 squared. And multiplied by -1 squared plus 0 squared, plus 2 squared, which is -4 over the square root of 70. And then, I'm going to make sure my calculator is in degrees and take the inverse. I get 119 degrees between those two vectors. So if I want to find out if two vectors are perpendicular with each other, what I'm trying to prove is that the dot product is equal to 0. So -1, 5, 2, t, and that the dot product is equal to 0. So I'm going to do my formula. So -1 times 2 plus 5 times t is equal to 0. -2 plus 5t equals 0. 5t equals 2, so 2t is equal to 2 over 5. So t would have to be 2 over 5 for A and B vectors to be perpendicular to each other. So this question is asking us to consider a right angle triangle, or it wants us to check and see if there is a right angle triangle. So we're given 3 different coordinates, but we first need to find the vectors that they create. So AB would be 6 minus 2 and -1 minus 1, which is 4 and -2. BC is going to be 5 minus 6 and -3 minus -1. So -1 and -2. And AC will be 5 minus 2 and -3 minus 1. So 3 and -4. Now, if we want to find out if there is a right angle between any of those, we can just pick 2 of them to find out if their their dot product is equal to 0. So I'll just pick the first 2. So 4 times -1 plus -2 times -2. Ooh, -4 plus 4 is equal to 0. So we got it right away. If that didn't work, then we would try taking the dot product of 2 different ones, and so on and so forth. Use vector methods to determine the measure of angle ABC. So it looks like we are finding this angle here, and what you need to be able to visualize is that this is going from the back top right corner to the front bottom left, and then here along the side. Now, if you remember our 3-dimensional space, we have X, Y, and Z. So we actually are given enough information to determine that A is the coordinate in the x direction. Let's see, it's going to go from the back to the front, so it's right here, which is 2. In the y direction, that's along the horizontal, or what looks to be the horizontal. So from B to A, it's going to the left, so that's going to be -4 units. And to the Z, it's going down to get to A, which is -3 units, because the height is negative. So let me say that again. If we go 2 units in the x direction, -4 in the y direction, and then down in the z direction, 3 units, that's going to get us to A. So we can actually call that vector BA. Now we want to go to C as well, because we're trying to find the angle between BA and BC. So BC, we're going to go, let's see, we're going to go half of 2 units, so like 1 unit in the x direction. And then we're not going left or right, we need to go actually directly down. So that means we have 0 and -3. So if we want to find the angle here, we're going to use cosine of angle ABC, which is vector BA dot BC over the magnitude of BA and BC. So first we need to find the dot product of these. So 2 times 1 plus -4 times 0 plus -3 times -3, which is 2 minus 4 plus 9, which is 7. We get 7 over, now the magnitude, so 2 squared is 4, plus 4 squared is 16, plus -3 squared is 9, and then BC, 1 squared, 0 squared, and -3 squared. We add that up, and oops, I made a boo-boo. Wonder if you guys noticed it. Probably. This should be a 0. Plus 0, so this should be 11. Then when you take the inverse cosine, you end up getting 49.8 degrees.